but he is our state climatologist, and anytime we get into situations where we want to talk about long-term weather patterns, he is the guy that we call on to bring us information. So, Dr. Gammon, we do appreciate you being here with us today, and I will turn the microphone over to you.
All right, it helps that I unmute myself. Thank you for hanging out here. One advantage of doing these remote webinars is that when previous speakers say I'm going to talk about something, I can very easily change my slides to make sure I do talk about it. So I'm going to cover what's been going on with drought recently, basically where we are right now in the Southeast Texas region. Some of the tools I use for tracking that. I'm going to talk about drought in more general terms as to how it's changing over time, different factors affecting that. Then I'm going to focus on the outlook for the next several months regarding rainfall and drought. So when we think about drought, the most obvious question is how much rain have we gotten? And drought generally requires significantly less rainfall than normal. Here's a comparison of rainfall that we've gotten in College Station in a variety of particular years. The boring line, the brown one, is the normal amount of rainfall. And I've started the graph back in July, and I've gone through to the end of May. And basically what we're doing here is just adding up the rainfall that occurs in each day to get an overall total. And you can also see how it evolves over time. In College Station, we get rainfall throughout the year, so the normal line is almost diagonal, but if you look real close, you can see it's a bit steeper in October where it tends to be wet, and again in May it tends to be wet also. This green line, the one right below the brown one, is what we just had. That's the rainfall since July of 2019. And as you can see, it's well below normal. We've gotten about 11 inches less rain than we normally would. And where that line is parallel to the brown line, we've actually received close to normal rain since the beginning of spring, but they diverged back in September all the way through January, February. So that's when we built up this rainfall deficit. And since then, we really haven't reduced that deficit, but we've sort of made a drought sandwich out of it. We had near normal to above normal rainfall recently, and the past several years, 2015 through 2018, were for the most part very wet also. So there's a lot of moisture deep down in the soil, the water table doing fairly well around here. And there's a decent amount of moisture right in the topsoil. But if we turn dry over the next few weeks with the high temperatures, that topsoil moisture can go away and we can start again feeling the effects and seeing the effects of the relative lack of rain that we had around here in the fall and winter. For comparison purposes, I plotted the 5 driest historical periods, the same plot, as well as the 5 or 6 wettest of all time. The driest turns out to be 1924 to 1925. It's really not an accident that a lot of the big old trees in the southeastern part of the state are somewhere around 90 years old, because this drought in 24 and 25 killed an awful lot of trees. Some of the other droughts that show up, this second driest was 2011, third driest was 1917, and then we get a couple droughts in the 1950s. So those droughts were even drier than the present one, obviously, but not by a very large amount, about 7 or 8 inches less. 24, 25 was completely devastating. On the wet side, some of the recent years actually have been wet. 2015, 2016, 2014, and 2015 are two of the 6 wettest such periods on record. So we've really been going through some whipsaws of the weather between very dry years and very wet years during the decade of the 2010s. And in fact, the previous year, from July of 2018 to June of 2019, turns out to have been one of the 6 wettest on record as well. So really some extreme weather recently, but you can find extreme weather also if you go back in the records. Show another comparison down in Victoria. Same basic story. They're actually even drier than the College Station region by about 15 inches below normal. And they've only been started catching up recently. We had serious drought developing there through early May, but then there's been some beneficial rain recently, which is really no more than normal for Victoria. Other areas around there have done better. And again, this drought isn't the driest ever, but their past few decades have seen some of the wettest years on record also. This is what the overall rainfall pattern looks like over the past year in terms of the percent of normal precipitation. The greens and blues are wetter than normal. The yellows and oranges are drier than normal. And as you can see, it's a mixed bag for Southeast Texas. I highlighted College Station and Victoria, which are on the dry side. Closer to Houston, wetter, and of course where Tropical Storm Imelda made landfall, 12-month precipitation totals are pretty substantial. Looking more closely at the past 3 months, that has been mostly wetter than normal, except for coastal regions. You can see lots of areas that were below normal, even just looking at the past 3 months. And the past month, this is really where the had its tables turned, with South Texas and Southeast Texas mostly being wetter than normal, but areas farther north, including parts of East Texas, drier than normal. So we may see drought emerging to the north as well. I'll just mention as a side that as drought has improved in South and Southeast Texas, it's getting rapidly worse in the Texas Panhandle, and that's where a lot of attention is going right now. They've gotten almost no rain in parts of the Texas High Plains in the past couple months. We try to put this in historical perspective by creating drought indices, because really percent of normal doesn't tell you how unusual the drought is. Is 70% of normal something that is historic, or is it something fairly ordinary? In fact, in West Texas, because you get lots of dry years and then a few very wet years, 70% of normal can actually be a normal circumstance that you would see in a large fraction of years. So here I've color-coded the accumulated rainfall according to the U.S. Drought Monitor colors, where yellow is abnormally dry, the tan is moderate dryness, orange is severe dryness, etc. And these colors correspond to how frequently you'd expect these things to happen. So abnormally dry, you'd reach that threshold maybe about 30% of the time. Moderately dry, only about 20%. Severely dry, 10%. Extremely dry, 5%. Exceptionally dry, 2%. In reality, if you look at what's happened with the U.S. Drought Monitor, which is the second link on this slide, you get extreme and exceptional drought showing up more frequently than you expect. And there's 2 reasons for that. One is the Drought Monitor is sort of a one-size-fits-all sort of depiction of drought. So you can have a short-term drought that's affecting forage, where it's been dry for a few months, and that could be severe or extreme or exceptional. Or then you can go through a period where you get decent amounts of rain to keep the topsoil fairly moist, but you don't get much runoff. And so the streams start suffering, and the reservoir levels and stock tanks start going dry. And that's a sort of a hydrologic drought that's on a longer time scale. So since you can have different types of droughts, and the Drought Monitor really doesn't distinguish between those in its colors, you actually get drought more frequently than those percentiles, as we call them, would indicate. Second reason is drought is actually, there's some evidence drought may be getting worse. And I'll talk about the reasons for that in a moment. The link on the top is a great place to go to for looking at the patterns of rainfall. If you're worrying about rainfall in places where you don't have a rain gauge or haven't been able to visit recently, you can look at fairly high detail. You can look at rainfall over the past day, the week, 2 weeks, month, 2 months, and so forth. And you can also look at a historical map for a month or a year to see how conditions today compared to conditions, say, during the last drought. And that can be a useful reference point because you may be wondering whether your pastures are doing as well in this drought as they did in the last drought. You can tell whether it's due to this drought being more or less severe, or whether there may be some other factor being involved. The only shortcoming of both of these plots, the precip map and the Drought Monitor map, is that they only go back about 15 or 20 years. By the way, for the Drought Monitor map, Vanessa talked about being able to zoom in on the maps by clicking on the states. There's also a bunch of pull-down menus across the top that let you dig into greater detail. So here's an example of that. If you go to the data pull-down and select time series, and then choose a particular county to plot, you can actually see drought over the past 20 years. And of course, the drought of 2011 shows up in this particular case. This is Madison County, so we're looking at the Norman G area where you saw the photos. The only exceptional drought was in 2011, but we had severe drought in 2009, briefly in 2013, and again in summer of 2015. So this is another good way of looking at the historical view. Colors don't necessarily tell the whole story because drought in the winter has different impacts than drought in the summer. So you have to pay attention to when during the year these droughts occurred. If you go to the actual website, you can actually zoom in on particular time periods and look at when a previous drought developed and when it went away, so you can compare how your pastures did under those circumstances versus how they'd be doing now, and whether the different nature of the drought has something to do with it. For the longer perspective, I like this particular website because you can look at how rainfall over a month or 3 months ranks compared to the historical record, which is usually 100 years or more. So that'll tell you really whether you've got something going on that should happen like once a decade or so, or whether you got something going on that's truly unusual. In case you're trying to madly jot down this information, I'll keep a little text box up for the next few slides so you can do that. So about how drought is getting worse or better. Well, for rainfall, over the long view, going back past 125 years or so, rainfall has increased across southeast Texas. It's gone up by more than 5% per century everywhere in the eastern half of the state. In extreme southeast Texas, partly driven by Harvey and Imelda, it's gone up by more than 15%. But you can see 10% to 12% increase is a pretty good representative number. So by itself, that would indicate the drought would be becoming less severe over time, or at least that it has in the past. Going forward, we'd like to know whether that trend is likely to continue. And to tell you the truth, I'd like to know whether it's likely to continue also. But the best tool we have is not a real good tool. It's climate models, which don't do a very good job of changing rainfall patterns. And in fact, in Texas, we sort of have a mixed bag with the models, and on the whole, they're predicting northern Mexico be drier than normal going forward. They're predicting the northern United States be wetter than normal going forward, and there's pretty good model consistency with that it gets wetter to the north. But Texas is sort of on the dividing line, where it's not really clear whether rainfall will increase or decrease going forward, according to the computer models. So this historical trend that we have, we can cross our fingers and hope it's going to continue, but there's a bit of evidence from the models that it won't, and you can weight that evidence however much you want to. I personally think that rainfall is likely to stop increasing so dramatically as it has in the past, but we're probably not going to dry out substantially like Mexico is likely to do. But the total amount of rainfall, even though that's what we normally think of as drought, is not the only factor driving drought. Temperature matters as well. As you know, when you get a stretch of very hot weather, the effects of the last thunderstorm that went through can be gone within a couple days. And so what matters not just is how much rain gets into the soil, but also how rapidly that rain gets out of the soil. And temperature has a lot to do with how rapidly that water evaporates. Here's a plot of temperatures from Victoria over the historical period. And what we had so far this year, over the same 11 months that I looked at for rainfall, has basically a tie for the fourth warmest period on record for Victoria. So on top of having less rain than normal, we have having higher temperatures than normal. If temperatures had been like they were last year, the drought conditions in the Victoria area would not have been nearly so severe. On the other hand, while we could wish for something like that, it's not likely to happen because drought tends to go hand in hand with high temperatures anyway. If you have less rain, that means with less water evaporating, the soil can heat up faster when the sunlight's shining on it. Sun's energy can be used to evaporate water, or the sun's energy can be used to heat up the soil and heat up the leaf surfaces. And if there's not as much water available to evaporate, the only thing that energy can do is cause heat. Plus, if it's not raining, it's probably not very cloudy, so you're even getting more solar radiation than you would in the first place. So unfortunately, when it's hot, it tends to be dry, and vice versa. You see the same thing for College Station, not quite as warm historically, but definitely this is one of the wet years. And I mentioned the previous year this is one of the dry years. The previous year was one of the wet years. And sure enough, temperatures are running over 3 degrees warmer this year than they were last year. And that's the same sort of trend you can see across all of Texas. This is Texas average temperatures. And depending on how far back you go, you can find either a gradual warming trend or a steeper warming trend. I'll mention that this warming trend since the mid-70s is consistent with what the computer models simulate. And furthermore, we have a better handle on the causes of rising temperatures. So an increase of temperatures is indeed expected to continue in the future. Right now, it's been going up by around 0.5 degree Fahrenheit per decade. And there's some variability across the state, but not much. Certainly not nearly as much as with rainfall. There's no place here where temperatures are going down. So that's another thing that makes a continued rise of temperatures a pretty sure bet. Now, the timing of rainfall matters, and the intensity of rainfall matters. If you get a sudden cloud burst, you get a lot of runoff because rainfall can't infiltrate into the soil quickly enough. So it matters whether rainfall is becoming more intense, so that it comes in basically shorter bursts. And unfortunately, this is another bad news sort of thing, because if you look at the most intense rainfall, it is indeed becoming more intense, even as overall rainfall amounts are going up slowly. Intense rainfall is going up even more. We're seeing different counties have different rates, but it's around 20% increase in the intensity of basically the wettest day that you would expect to have in a century. And the spottiness of this is because we're dealing with extreme events, which historically may have happened in one place, but not in another place. But there's a lot more greens than oranges. So this is increase in general. And you see the same thing if you look at Louisiana, Oklahoma, and basically all of the eastern United States. We're seeing an increase of intensity of rainfall. And that's an expected consequence of the rising temperatures, because warmer air can hold more moisture. So when you have a storm system that's producing lots of rain, it's able to produce even more rain because the temperatures are warmer and it's carrying more water that it can deliver in the form of rain. But then when we worry about drought, we're not worrying specifically about soil moisture or runoff. We're worrying about the consequences of that to rangeland, to the natural environment, what have you. And that then depends upon what plants do with that water. Since one of the drivers of higher temperatures is increased carbon dioxide, we have to think about how plants respond to that increased carbon dioxide in the first place. Carbon dioxide is basically the building material for plants. That's how they get their carbon. And when they take up carbon dioxide from the atmosphere, they're also losing water vapor through their stomata. And with the greater concentrations of carbon dioxide, they don't need to lose as much water to get the carbon dioxide they need. So that means that plants are more drought resilient when you have higher carbon dioxide levels. So now we got a good news sort of thing. And we got this trade-off. What's going to be more important? Is it going to be the change in rainfall? Is it going to be the change in temperature? Is it going to be the change in carbon dioxide? All of these are affecting the plant growth differently. In truth, it looks like the change in temperatures is probably going to have the biggest effect. We're probably going to see more plant growth, but also more plant stress during drought. But all of those things actually end up getting outweighed by natural variability. Rainfall in Texas is extremely variable. You can see that just by comparing last year to this year. So while these other factors I've talked about in terms of long-term change are going to matter going forward over the next several decades, what matters for the next year or 2 years is back to how much rain we get, because that can change by a factor of 2 from 1 year to the next. Difference between a wet year and a dry year. So let's focus on that and see what's going on with that. The main factor for natural variability affecting Texas is El Nino and La Nina. And I know you've heard those words before. The impact of El Nino is from the article. EL stands for extra liquid. We get lots of rain on average during an El Nino year in Texas. And the farther south you go, the greater the average percent increase of rainfall during an El Nino year. Now, it's only during November through March that we see a big effect here, because the way our weather gets affected is by changes in the jet stream. Jet stream carries winter storms from west to east, and in the wintertime, the jet stream is far enough south to affect our weather. In the summer, it moves to the north, and jet stream changes really don't have any effect on us. So that's why El Nino helps us make seasonal predictions in the wintertime, but not so much in the summertime. And El Nino is when temperatures are warm in the tropical Pacific, La Nina is when temperatures are cool in the tropical Pacific, and just like its opposite temperatures, it has an opposite effect on our climate. LA stands for less agua in our case. It tends to be relatively dry during the cool season, and mainly those effects again are during a slightly longer period of time than El Nino, but mainly kicks in around October, and by May the effects tends to be going away. And here's an example for La Nina for fall and winter, how much rain you get compared to normal. The browns and yellows are less rain than normal. You can see parts of Southeast Texas, on average, you can expect 3 to 4 less inches of rain in the fall during a La Nina year, and then another 1 or 2 inches less rain in the winter. And it's not just Texas being affected, it's basically all of the southern United States. This is, again, the average. You can have a wetter than normal year during La Nina, but it's going to be the exception rather than the rule. Now, El Nino and La Nina go through a sort of a typical life cycle. They tend to develop in the summer and fall and hang around through the winter time. So once you get into June or July timeframe, you can actually make decent forecasts of what might happen next fall or winter with El Nino or La Nina, and therefore get some insight as to what to expect as to when we start getting relief from the summer dry conditions and how much moisture we might be able to replenish into the soil in the wintertime. So let's now take a look at the forecast for El Nino and La Nina. And what scientists focus on for this is the tropical Pacific. The El Nino region is basically the central tropical Pacific, the area along the equator south of the Hawaiian Islands. And you're looking here at the whole tropical Pacific from Central America and South America across to Australia and New Guinea. And you might expect this whole thing to look like one big warm bathtub with warm water temperatures. 30 Celsius is about 86 degrees Fahrenheit, so quite comfortable to swim in off the coast of New Guinea. On the other hand, you can see along the coast of South America, it's relatively cool. Water temperatures would be about 70 degrees Fahrenheit. You got this tongue of cold water right here along the equator. Consequence of this is that the thunderstorm activity in the tropics is mainly out here in the western Pacific. But if these temperatures warm up, thunderstorms spread out, that affects the weather patterns, that brings us El Nino conditions. If the cool water gets reinforced, then the thunderstorms are confined even farther over to the west. That affects the weather patterns, give us dry conditions. The way scientists actually can predict what's going to happen here is by looking essentially beneath the hood of the tropical Pacific. So if you imagine looking from west to east along the equator and looking at a curtain that's suspended in the water and seeing what temperatures look like, not just at the top of the curtain, at the surface, but also down below, you would see something like this. The warm water is over here in the western tropical Pacific, but it's only about 100, 150 meters deep, a few hundred feet. Colder water right below that. And out here in the East Pacific, the cold water has made it almost all the way to the surface. That's because the trade winds are blowing the warm water to the west constantly, and cold water from below is being brought to the surface to replenish it, and then it heats up as it stays on the surface and gets that tropical sunlight. So you can imagine this circulation where the water is being drawn constantly from east to west, and cold water coming up to replace it. As that circulation gets stronger, you affect the temperatures at the surface. This is how those patterns compare to normal. They're actually much colder than normal right now, right near that area where temperatures are vary a lot, which means the cold water is a lot higher, a lot closer to the surface than it normally is. So we're expecting that cold water to actually reach the surface and allow for La Nina conditions to develop. So cold La Nina, less agua, would mean less rainfall in the fall and winter for Texas. So that's what we're looking at for our forecast. Now, that only starts having a big effect in the fall and winter. On the shorter term, scientists rely a bit more on climate models to predict how the patterns of sea surface temperatures in the Pacific and the Atlantic are going to affect things. And what those models are saying is that June is likely to be wetter than normal. This 40% basically means a 40% chance of being substantially above normal rainfall. And green obviously is color coded to represent wetter than normal conditions. And indeed, that seems to be consistent with what we're seeing happening. We got a tropical storm last time I checked in the Bay of Campeche. There may be a tropical disturbance making landfall somewhere along the North Gulf Coast in about a week or so, and that'll bring a lot of rain to at least some parts of the Gulf Coast. Don't know if it'll be Texas yet or not. On the bottom here is the temperature outlook. The oranges mean substantial chances of quite a bit warmer than normal. The main factor there is literally the long-term temperature trend. We define normal as the average from 1981 to 2010. And temperature going up by 0.5 degree a decade. So our new normal, so to speak, is already about 1 degree or 1.5 degrees warmer than what we call normal in the weather records. Stay tuned another year or two. Our normal reference period is going to shift to 1991 to 2020. It goes decade by decade. And so at least normal in a few years will be closer to what to expect. But right now, since we can expect things above normal, that's what the seasonal forecast shows. So that's for the upcoming month. Then the remainder of the summer, rainfall chances go down a bit. Most of southeast Texas is in the white here, which is labeled EC. The A stands for above normal. EC literally stands for equal chances for above normal, near normal, and below normal, which obviously is not terribly useful, except that it is saying you don't need to plan on doing something unusual, given the forecast. Although I like to think of the EC standing for extremely clueless, especially when most of the United States has shown that way. But rainfall is notoriously hard to predict in the summer, partly because it's so dependent on where a particular tropical disturbance is going to go. That can make or break an entire summer season's worth of rainfall. Temperature forecast is easy. We have a warming trend. It's likely to be warmer than normal this summer, just like it's likely to be warmer than normal this fall and warmer than normal this winter. But if we start looking at the precipitation outlook for the fall and winter, this is summer again, but we expect La Nina to develop in the fall, so we would expect an increased probability of below normal rainfall in the fall. And indeed, that's what starts showing up in the seasonal forecast for the fall. The winter forecast a little bit farther out, but at least they're predicting below normal rainfall for the Four Corners region. We will see, as I mentioned, as you get into June and July, those forecasts start being a lot more solid. The seasonal outlooks come out in about the middle of the month, so pay attention to what the forecast looks like. Let's see, the next release should be June 18th, if that's a Thursday, or should be close enough to that. Take a look at what it's showing. That'll probably be a much better view of what's likely to happen in the fall and winter. And yeah, I know the rainfall in the summer, it makes a lot more difference to whether your pastures are going to survive, and I wish we did have better ways of predicting summer rainfall, but unfortunately we do not. The website for all of those graphics is the Climate Prediction Center. You can just Google Climate Prediction Center if you want. The actual URL is here at the top. It's not very easy to navigate, so I'll show you where to go. If you wanted to look at what's going on specifically with El Nino and La Nina, you can click on this link. If they have a recent update, it'll actually be in the climate news section. Or if you don't care about all those causes and stuff and just want to look at the forecast, well, you can find those here, the 3-month outlooks. You can click on the 3-month outlook header, and that'll take you to the outlooks for basically every possible season from now until same time next year. And there are other outlooks on here. You can look at shorter range outlooks as well. The Drought Monitor and the outlooks for the Drought Monitor are available from this page also. And I'll give you one bit of warning about the Drought Monitor seasonal outlooks. We've looked at the skill in the outlooks, and most of the skill in predicting what's going to happen to drought over the next 3 months comes from the weather forecast for the next week or week and a half. Don't even bother looking at the seasonal outlook if it's more than 2 weeks old, because most of what it was forecasting to happen would already have happened. Pay a bit more attention to the actual outlooks for precipitation over the next couple of weeks, or the rest of the month, or the following months. But I personally would not recommend following the seasonal outlook very closely, except for when it comes out about the same time as the 3-month seasonal forecasts come out. So latest drought's over, but we still are kind of vulnerable because we haven't made up the rainfall deficit that accumulated over the fall and winter. Temperature trends are increasing the rate of evaporation, and that's expected to continue. Well, meanwhile, carbon dioxide is reducing transpiration from plants, and that's expected to continue also. So it's sort of a good news, bad news thing. As I mentioned, temperature probably is the bigger effect, which means for the same amount of rainfall, droughts are going to have bigger impacts. Meanwhile, in the shorter range, we have likely development of La Nina, which means less agua once we start getting past the summer and get into the October-November timeframe. That's likely now. We'll have a better handle on it in a month or two, so stay tuned to the forecast for that. Depending on whether we have time to ask questions or whether you think of something later, you can contact me by email. I've got my email address here. It's easier than all the websites that I link to. Yeah, thanks for hanging out for the entire program, and I'll be happy to take questions if we can.